Let's go ahead and understand text mining in detail. Let's first understand what text mining is. Text mining is the technique of exploring large amounts of unstructured text data and analyzing it in order to extract patterns from the text data. It is aided by software that can identify concepts, patterns, topics, keywords, and other attributes in the data. It utilizes computational techniques to extract and summarize the high-quality information from unstructured textual resources. Let's understand the flow of text mining. There are 5 techniques used in text mining system. Information extraction or text pre-processing. This is used to examine the unstructured text by searching out the important words and finding the relationships between them. Categorization or text transformation attribute generation. Categorization technique labels the text document under one or more categories. Classification of text data is done based on input-output examples with categorization. Clustering or attribute selection. Clustering method is used to group text documents that have similar content. Clusters are the partitions, and each cluster will have a number of documents with similar content. Clustering makes sure that no document will be omitted from the search, and it derives all the documents that have similar content. Visualization technique. The process of finding relevant information is simplified by visualization technique. This technique uses text flags to represent a group of documents or a single document, and compactness is indicated using colors. Visualization technique helps to display textual information in a more attractive way. Summarization or interpretation or evaluation. Summarization technique will help to reduce the length of the document and summarize the details of the documents. It makes the document easy to read for users and understand the content at the moment. Let's understand the significance of text mining. Document clustering. Document clustering is an important part of text mining. It has many applications in knowledge management and information retrieval. Clustering makes it easy to group similar documents into meaningful groups, such as in newspapers where sections are often grouped as business, sports, politics, and so on. Pattern identification. Text mining is the process of automatically searching large amount of text for text patterns and recognition of features. Features such as telephone numbers and email addresses can be extracted using pattern matches. Product insights. Text mining helps to extract large amounts of text, for example, customer reviews about the products. Mining consumer reviews can reveal insights like most loved feature, most hated feature, improvements required, and reviews of competitors' products. Security monitoring. Text mining helps in monitoring and extracting information from news articles and reports for national security purposes. Text mining makes sure to use all of your available information. It is a more effective and productive knowledge discovery that allows you to make better informed decisions, automate information-intensive processes, gather business-critical insights, and mitigate operational risks. Let's look at the applications of text mining. Speech recognition. Speech recognition is the recognition and translation of spoken language into text and vice versa. Speech often provides valuable information about the topics, subjects, and concepts of multimedia content. Information extraction from speech is less complicated, yet more accurate and precise than multimedia content. This fact motivates content-based speech analysis for multimedia data mining and retrieval, where audio and speech processing is a key enabling technology. Spam filtering. Spam detection is an important method in which textual information contained in an email is extracted and used for discrimination. Text mining is useful in automatic detection of spam emails based on the filtering content. Using text mining, an email service provider such as Gmail or Yahoo Mail checks the content of an email, and if some malicious text is found in the mail, then that email is marked as spam and sent to the spam folder. Sentiment analysis. It is done in order to determine if a given sentence expresses positive, neutral, or negative sentiments. Sentiment analysis is one of the most popular applications of text analytics. The primary aspect of sentiment analysis includes data analysis of the body of the text for understanding the opinion expressed by it and other key factors comprising modality and mood. Usually, the process of sentiment analysis works best on text that has a subjective context than on that with only an objective context. E-commerce personalization. Text mining is used to suggest products that fit into a user's profile. Text mining is increasingly being used by e-commerce retailers to learn more about the consumers, as it is the process of analyzing textual information in order to identify patterns and gain insights. E-commerce retailers can target specific individuals or segments with personalized offers and discounts to boost sales and increase customer loyalty by identifying customer purchase patterns and opinions on particular products. Let's look at Natural Language Toolkit Library in detail. Natural Language Toolkit is a set of open-source Python models that are used to apply statistical natural language processing on human language data. Let's see how you can do environment setup of NLTK. Go to Windows Start and launch Python Interpreter from Anaconda prompt and enter the following commands. Enter command Python to check the version of Python installed on your system. Enter import NLTK to link you to the NLTK library available to download. Then enter NLTK.download function that will open the NLTK download window. Check the download directory, select all packages, and click on Download. This will download NLTK onto your Python. Once you have downloaded the NLTK, you must check the working and functionality of it. In order to test the setup, enter the following command in Python idle. From nltk.corpus import brown, brown.word parenthesis parenthesis. The brown is an NLTK corpus that shows the systematic difference between different genres available. Words function will give you the list available words in the genre. The given output shows that we have successfully tested the NLTK installed on Python. Let's now understand how you can read a specific module from NLTK Corpora. If you want to import an entire module from NLTK Corpora, use asterisk symbol with that module name import command. Enter the command from nltk.book import asterisk. It will load all the items available in NLTK's book module. Now, in order to explore brown corpus, enter the command nltk.corpus import brown. This will import brown corpus on the Python. Enter brown.categories function to load the different genres available. Select a genre and assign that genre to a variable using the following syntax. Variable name is equal to brown.words. Categories is equal to genre name. Now, in order to see the available words inside the selected genre, just enter the defined variable name as a command. Let's understand text extraction and pre-processing in detail. So let's first understand the concept of tokenization. Tokenization is the process of removing sensitive data and placing unique symbols of identification in that place in order to retain all the essential information concerned with the data by its security. It is a process of breaking running streams of text into words and sentences. It works by segregating words using punctuation and spaces. Text extraction and pre-processing n-grams. Now let's look at what n-gram is and how it is helpful in text mining. N-gram is the simplest model that assigns these probabilities to sequences of words or sentences. N-grams are combinations of adjacent words or letters of length n in the source text. So n-gram is very helpful in text mining when it is required to extract patterns from the text. As in the given example, this is a sentence. All of these words are considered individual words and thus represent unigrams. A 2-gram or bigram is a two-word sequence of words like this is a, or a sentence, And a threegram or trigram is a three-word sequence of words like "this is a" or "is a sentence." Let's now understand what stop words are and how you can remove them. Stop words are natural language words that have negligible meaning, such as a, an, and, or, the, and other similar words. These words also will take up space in the database or increase the processing time, so it is better to remove such words by storing a list of stop words. You can find the list of stop words in the NLTK data directory that is stored in 16 different languages. Use the following command to list the stop words of English language defined in NLTK corpus. Importing NLTK will import the NLTK corpus for that instance. Enter from nltk.corpus import. Stop words will import stop words from NLTK corpus. Now set the language as English, so use set function as set under braces stopwords.words. Set genre as English. Stop words are filtered out before processing of natural language data, as they don't reveal much information. So as you can see in the given example, before filtering the sentence, the tokenization of stop word is processed in order to remove these stop words, and the filtering is applied in order to filter the sentence based on some criteria. Text extraction and pre-processing stemming. Stemming is used to reduce a word to stem or base word by removing suffixes such as helps, helping, helped, and helper to the root word help. The stemming process or algorithm is generally called a stemmer. There are various stemming algorithms such as Porter stemmer, Lancaster stemmer, Snowball stemmer, etc. Use any of the stemmers defined under NLTK stem corpus in order to perform stemming as shown in the example. Here we have used Porter stemmer. When you observe the output, you will see that all of the words given have been reduced to their root word or stem. Text extraction and pre-processing lemmatization. Lemmatization is the method of grouping the various inflected types of a word in order that they can be analyzed as one item. It uses vocabulary list or morphological analysis to get the root word. It uses WordNet database that has English words linked together by their semantic relationship. As you can observe, the given example, the different words have been extracted to their relevant morphological word using lemmatization. Text extraction and pre-processing POS tagging. Let's now look at different part-of-speech tags available in the National Language Toolkit library. A POS tag is a special label assigned to each token or word in a text corpus to indicate the part of speech and often also other grammatical categories such as tense, number either plural or singular, case, etc. POS tags are used in text analysis tools and algorithms and also in corpus searches. So look at the given example. Here Alice wrote a program is the source text given. The POS tags given are Alice is a noun, wrote is a verb, a is an article, and program is an adjective. Look at the given example to understand how POS tags are defined. So the given sentence or paragraph contains different words that represent different parts of speech. We will first use tokenization and removal of stop words, and then allocate the different POS tags. These are shown with different words in the given sentence. POS tags are useful for lemmatization in building named entity recognition and extracting relationships between words. Text extraction and pre-processing named entity recognition. Now let's understand what named entity recognition is all about. NER seeks to extract a real-world entity from the text and sorts it into predefined categories, such as names of people, organizations, locations, etc. Many real-world questions can be answered with the help of name entity recognition. Were specified products mentioned in complaints or reviews? Does the tweet contain the name of a person? Does the tweet contain the person's address? As you can see in the given example, Google, America, Larry, Page, etc. are the names of a person, place, or an organization. So these are considered named entities and have different tags such as person, organization, GPE or geopolitical entity, etc. NLP process workflow. Now you have an understanding of all NLTK tools. So now let's understand the natural language processing workflow. Step 1, tokenization. It splits text into pieces, tokens, or words and removes punctuation. Step 2, stop word removal. It removes commonly used words such as the, is, are, etc., which are not relevant to the analysis. Step 3, stemming and lemmatization. It reduces words to base form in order to be analyzed as a single item. Step 4, POS tagging. It tags words to be part of speech such as noun, verb, adjective, etc. based on the definition and context. Step 5, information retrieval. It extracts relevant information from the source. Demo 1, Brown Corpus. Problem statement. The Brown University Standard Corpus of Present-Day American English, also known popularly as Brown Corpus, was compiled in the 1960s as a general corpus in the field of corpus linguistics. It contains 500 samples of English language text totaling roughly 1 million words, compiled from works published in the United States in 1961. We will be working on one of the subset dataset and perform text processing tasks. Let us import the NLTK library and read the CA_10 corpus. Import NLTK. We will have to make sure that there are no slashes in between. Hence, we will use the replace function within pandas for the same. Let's have a look at the data once. Tokenization. After performing sentence tokenization on the data we obtain, similarly, after applying Sentence Tokenizer, the resulting output shows all individual words, tokens. Stop word removal. Let's import the stop word library. From nltk.corpus, import stop words. We also need to ensure that the text is in the same case. NLTK has its own list of stop words. We can check the list of stop words using stopwords.words and English inside the parenthesis. Map the lowercase string with our list of word tokens. Let's remove the stop words using the English stop words list in NLTK. We will be using set checking as it is faster in Python than a list. By removing all stop words from the text, we obtain Often we want to remove the punctuations from the documents too. Since Python comes with batteries included, we have string.punctuation. From string, import punctuation. combining the punctuation with the stop words from NLTK. Removing stop words with punctuation. Stemming and lemmatization. We will be using stemming and lemmatization to reduce words to their root form. For example, walks, walking, walked will be reduced to their root word walk. Importing Porter Stemmer as the stemming library. From NLTK.stem, import Porter Stemmer. Printing the stem words. Import the WordNet lemmatizer from NLTK.stem. Printing the root words. We also need to evaluate the POS tags for each token. Create a new word list and store the list of word tokens against each of the sentence tokens in Data 2. For I in tokenized, also, we will check if there were any stop words in the recently created word list. We will now tag the word tokens accordingly using the POS tags and print the tagged output. For our final text processing task, we will be applying named entity recognition to classify named entities in text into predefined categories such as the names of persons, organizations, locations, expressions of times, quantities, monetary values, percentages, etc. Now press the tagged sentences under the chunk parser. If we set the parameter binary equals true, then named entities are just tagged as NE. Otherwise, the classifier adds category labels such as person, organization, and GPE. Create a function named as extract entity names along with an empty list named as entity names. We will now extract named entities from a NLTK chunked expression and store them in the empty created above. Again, we will set the entity names list as an empty list and will extract the entity names by iterating over each tree in chunked sentences. Great, we have seen how to explore and examine the corpus using text processing techniques. Let's quickly recap the steps we've covered so far. 1. Import the NLTK library. 2. Perform tokenization. 3. Perform stemming and lemmatization. 4. Remove stop words. 5. Perform named entity recognition. Structuring sentences, syntax. Let's first understand what syntax is. Syntax is the grammatical structure of sentences. In the given example, this can be interpreted as syntax, and it is similar to the ones you use while writing codes. Knowing a language includes the power to construct phrases and sentences out of morphemes and words. The part of the grammar that represents a speaker's knowledge of these structures and their formation is called syntax. Phrase structure rules are rules that determine what goes into a phrase, that is, constituents of a phrase and how the constituents are ordered. Constituent is a word or group of words that operate as a unit and can be used to frame larger grammatical units. The given diagram represents that a noun phrase is determined when a noun is combined with a determiner, and the determiner can be optional. A sentence is determined when a noun phrase is combined with a verb phrase. A verb phrase is determined when a verb is combined optionally with the noun phrase and prepositional phrase. And a prepositional phrase is determined when a preposition is combined with a noun phrase. A tree is a representation of syntactic structure of formulation of sentences or strings. Consider the given sentence. The factory employs 12.8% of Bradford County. What can be the syntax for pairing this statement? Let's understand this. A tree is produced that might help you understand that the subject of the sentence is the factory. The predicate is employs, and the target is 12.8%, which in turn is modified by Bradford County. Syntax parses are often a first step toward deep information extraction or semantic understanding of text. Rendering syntax trees. Download the corresponding .exe file to install the Ghost script rendering engine based on your system configuration in order to render syntax trees in your notebook. Let's understand how you can set up the environment variable. Once you have downloaded and installed the file, go to the folder where it is installed and copy the path of the file. Now go to System Properties, and under Advanced Properties, you will find the Environment Variable button. Click on that to open the pop-up box tab of the environment. Now open the bin folder and add the path to the bin folder in your environment variables. Now you will have to modify the path of the environment variable. Use the given code to test the working of syntax tree after the setup is successfully installed. Structuring sentences, chunking and chunk parsing. The process of extraction of phrases from unstructured text is called chunking. Instead of using just simple tokens which may not represent the actual meaning of the text, it is advisable to use phrases such as Indian team as a single word instead of Indian and team as separate words. The chunking segmentation refers to identifying tokens, and labeling refers to identifying the correct tag. These chunks correspond to mixed patterns in some way. To extract patterns from chunks, we need chunk parsing. The chunk parsing segment refers to identifying strings of tokens, and labeling refers to identifying the correct chunk type. Let's look at the given example. You can see here that yellow is an adjective, dog is a noun, and the is the determiner, which are chunked together into a noun phrase. Similarly, chunk parsing is used to extract patterns and to process such patterns from multiple chunks while using different parsers. Let's take an example and try to understand how chunking is performed in Python. Let's consider the sentence, "The little mouse ate the fresh cheese," assigned to a variable named cent. Using the word tokenize function under NLTK Corpora, you can find out the different tags associated with the sentence provided. So as you can see in the output, different tags have been allocated against each of the words from the given sentence using chunking. NP chunk and parser. You will now create grammar from a noun phrase and will mention the tags you want in your chunk phrase within the function. Here you have created a regular expression matching the string. The given regular expression indicates optional determiner followed by optional number of adjective followed by a noun. You will now have to parse the chunk. Therefore, you will create a chunk parser and pass your noun phrase string to it. The parser is now ready. You will use the parse parenthesis within your chunk parser to parse your sentence. The sentence provided is, "The little mouse ate the fresh cheese." This sentence has been parsed and the tokens that match the regular expressions are chunked together into noun phrases, NP. Create a verb phrase chunk using regular expressions. The regular expression has been defined as optional personal pronoun followed by 0 or more verbs with any of its type followed by any type of adverb. You'll now create another chunk parser and pass the verb phrase string to it. Create another sentence and tokenize it. Add POS tags to it. So the new sentence is, "She is walking quickly to the mall," and the POS tag has been allocated from NLTK Corpora. Now use the new verb phrase parser to parse the tokens and run the results. You can look at the given tree diagram, which shows a verb parser where a pronoun followed by two verbs and an adverb are chunked together into a verb parse. Structuring sentences, chinking. Chinking is the process of removing a sequence of tokens from a chunk. How does chunking work? The whole chunk is removed when the sequence of tokens spans an entire chunk. If the sequence is at the start or the end of the chunk, the tokens are removed from the start and end, and a smaller chunk is retained. If the sequence of tokens appears in the middle of the chunk, these tokens are removed, leaving two chunks where there was only one before. Consider you create a chinking grammar string containing three things: chunk name, the regular expression sequence of a chunk, the regular expression sequence of your chink. Here in the given code, we have the chunk regular expression as optional personal pronoun, followed by 0 or more occurrences of any type of the verb type followed by 0 or more occurrences of any of the adverb types. The chink regular expression says that it needs to check for the adverb in the extracted chunk and remove it from the chunk. Inside the chinking block with open curly braces and closing curly braces, you have created one or more adverbs. You will now create a parser from NLTK.regexp parser and pass the chink grammar to it. Now use the new chink parser to parse the tokens cent3 and run the results. As you can see, the parse tree is generated. While comparing the syntax tree of the chink parser with that of the original chunk, you can see that the token is quickly, adverb, chinked out of the chunk. Let's understand how to use context-free grammar. A context-free grammar is a four-tuple sum ntrs where sum is an alphabet and each character in sum is called a terminal. Nt is a set and each element in nt is called a non-terminal. R, the set of rules, is a subset of nt times the set of sum unt. S, the start symbol, is one of the symbols in nt. A context-free grammar generates a language L capturing constituency and ordering. In CFG, the start symbol is used to derive the string. You can derive the string by repeatedly replacing a non-terminal on the right-hand side of the production until all non-terminals have been replaced by terminal symbols. Let's understand the representation of context-free grammar through an example in context-free grammar. A sentence can be represented as a noun phrase followed by a verb phrase. Noun phrase can be a determiner, nominal. A nominal can be a noun. VP represents the verb phrase. A can be called a determiner. Flight can be called a noun. Consider the string below where you have certain rules. When you look at the given context-free grammar, a sentence should have a noun phrase followed by a verb phrase. A verb phrase is a verb followed by a noun. A verb can either be saw or met. Noun phrases can either be John or Jim, and a noun can either be a dog or a cat. Check the possible list of sentences that can be generated using the rules. Use the join function to create the possible list of sentences. You can check the different rules of grammar for sentence formation using the production function. It will show you the different tags used and the defined context-free grammar for the given sentence. Demo 2, Structuring Sentences. Problem statement. A company wants to perform text analysis for one of its data sets. You are provided with this data set named tweets.csv, which has tweets of 6 U.S. airlines along with their sentiments, positive, negative, and neutral. The tweets are present in the text column and sentiments in airline_sentiment column. We will be retrieving all tags starting with @ in the dataset and save the output in a file called references.txt. Let us first import the pandas library and read the tweets dataset. Extract the features, text, and airline sentiment. We will iterate through the dataset using regex. Find the relevant tweets. Now we will import the itertools module. It returns efficient iterators. The result is stored in a file named references.txt. Let's extract all noun phrases and save them in a file named noun phrases for _airline_sentiment review.txt. Here, _airline_sentiment has 3 different values, positive, negative, and neutral, so 3 files will be created. Now we will iterate all the leaf nodes and assign them to noun phrases variable. This means that the functions in itertools operate on iterators to produce more complex iterators. Using the map function, we will get all the noun phrases from the text. Putting it into list. Creating a file name in the name of review.txt.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.